All right, Algebra 2. In Chapter 12, we're getting into some of my favorite topics related to trig. Hopefully you'll like them as well. I think they're fun. But trig functions in right triangles is what we're going to focus on today. And if you'll remember from your geometry days, a right triangle, what's nice about a right triangle is that angle, that right angle stays locked no matter what, right? So as, as one angle, let's just say this angle here is variable, right? If that angle there, if you wanted to change that angle, and this one has to stay locked as a 90, then what's going to happen is, if you want that angle to be bigger, then we know that this opposite side here would have to be longer, right? And vice versa. If I wanted it to be smaller, if I want that angle to be smaller, then this would have to be shorter. So there's a relationship between angles and opposite sides. And that relationship is where we built trig. Okay, so the trig functions, just a reminder, you should know these already. If you know SOHCAHTOA, you know sine, cosine, and tangent, right? So SOHCAHTOA, we talk about that quite a bit. SOHCAHTOA. If you know that relationship, you're good with these guys. That's all SOHCAHTOA is, right? So we have SOHCAHTOA. All right, and then for the other trig functions, the ones that we don't necessarily use as much, just notice what happens. Okay, and I always get students asking me, how comes they did this? The sine associates with the cosecant, okay, and the cosine associates with the secant. I always have students asking me, they're always like, how come they didn't just call the cosecant the secant so that the S's match and the C's match? Kind of drives some people nuts. But just remember that the S's and C's do not match, and that sine and cosecant go together, and cosine and secant go together. All right, and the tangent piece is easy to know. But anyway, all this is flipping that, right? So that the opposite now is in the denominator. Okay, so each one of these is just the inverse, the flipped version of this whole thing. All right, so for trig functions, if you know SOHCAHTOA, you indirectly know the other ones. If you could just keep track that sine is linked with cosecant and cosine is linked with secant, and that all of those ratios are just the exact opposite. All right, so if you know a sine, you can flip it, and then all of a sudden you know the cosecant. This is what they're showing you down here, right? If I know the sine is 4/5, if I can find the sine of something, then if I ask you for the cosecant of that something, you just flip the fraction. That's all it's saying. All right, and remember that this is relating to sides, right? So the sine is an angle, and it's relating the opposite side of a triangle to the hypotenuse of the triangle. All right, so here we go. Let's do some of these. Example 1, find the values of the 6 trig functions for angle B. So if you remember this from geometry, I always said, so angle B is here. This is your perspective, right? It's like you're sitting there, and from that perspective, what are the trig functions? Okay, because opposite means something different for that perspective versus the perspective down here, right? So we're up there for B, and then I think I need to zoom out a little bit so you guys can see. There you go. Okay, so from B, let's go ahead and find the sine, the cosine, the tangent, and then at the same time we'll do the cosecant, the secant, and the cotangent. All right, so the sine from perspective B is going to be opposite over hypotenuse. So from here, the opposite is 15, the hypotenuse is 17. The hypotenuse always stays the same, it's always straight across from the 90. Okay, so this is 15 over 17. And then for the cosine, here we have adjacent. Well, adjacent to this, there's two things adjacent from here. Okay, there's the 17 and there's the 8. But here's the catch, you guys. I don't know if you remember this. The 17 always, you might want to even just label that the hypotenuse. The hypotenuse can never be the adjacent side. So that's how you keep that straight. Okay, so the cosine here will be 8 over hypotenuse, which is 17. And then we have the tangent, which is opposite over adjacent. So from here, opposite is 15, adjacent is 8. All right, so once we know those, you know, we're going to flip those fractions and find the other ones. So as long as you have them lined up correctly here, we're just going to flip these. So this would become 15 over 17. This one would become 17 over 8. This one would be 8 over 15. Okay, because they just mean the exact opposite. We flip them. And that's it. That's example 1. Easy points, right on the test, easy points. And then we have reciprocal functions. So notice that the cosecant, the secant, and the cotangent ratios are reciprocals of the sine, cosine, and tangent ratios respectively. These are called reciprocal functions. And it turns out that the cosecant is equal to 1 over the sine. Okay, so if you took 1 over, so just to show you what we mean by that. If I took 1 over 15 over 17, okay, to solve that out, that's the same thing as 1 over 1 times 17 over 15, which equals 17 over 15. So this thing is the same thing as 1 over sine. All right, and same with secant, 1 over cosine, and the same with cotangent, 1 over tangent. Because when you do that math out, it just flips the fraction, right? So that's what this is saying here, making sure you're clear on that. So here, if, for example 2, if tangent of b is 3 over 7, find the exact values of the remaining trig functions for b. Okay, so we know that, let's just draw a triangle. We know that this is a right triangle. Okay, so you can draw it however you want, but make sure there's a right angle. Let's just call this A, this B, this C. Okay, just don't call the right angle B. So from perspective B, we know that since tangent is equal to opposite over adjacent, right? The opposite of B would be 3, and the adjacent to B would be 7. Okay, so how do I find my other trig function? Well, now I have to use my Pythagorean theorem to get my hypotenuse, right? So I can do that. This is going to be 7 squared plus 3 squared is equal to, we'll call it c squared. And then this will become 49 plus 9. So 49 plus 9 gives me 58, I believe. So c is equal to the square root of 58. Okay, so this is the square root of 58. And then with that, you know, you might want to see if there's any perfect squares in there. So you might want to check, you know, 4, we know that 9 doesn't go in. You might want to check 16. 16 doesn't go in there evenly. 25 won't go in there evenly. So it looks like we're just going to leave it as the square root of 58. Okay, so now that we have that, the algebra here just gets a little trickier because we don't want to square root in our denominator, right? So let's just find these. So let's find all the functions, the trig functions for b. Okay, so the sine of b will be opposite over hypotenuse, which is 3 over root 58. Okay, but I can't leave it like that, so I have to multiply this by root 58 over root 58. All right, and when I do that, I get 58 on the bottom and 3 root 58 on the top. Okay, so that looks a little different than typical because we had that radical that we had to get into the numerator. All right, but it means the same thing. And then the cosine of this thing, cosine is adjacent over hypotenuse, which is going to be 7 over root 58. All right, so to solve this thing, we're going to do the exact same thing. And we get 7 root 58 over 58 for the cosine. All right, so there's that one. And then we know that the tangent, we already know that it's 3 over 7, so that was given to us, right? Okay, so let's find the other 3 now. Let's do that in blue. Sorry, I'm running out of space. Okay, so this gets a little tricky here, but not really. So I always go back to my original, because it makes life just a little bit easier. If I flip that back over, that's the same thing as, so the cosecant is the same thing as the square root of 58 over 3. Since I have the radical in the numerator there, that's perfectly legal, and this is okay. All right, if you try to flip it the other way around, then you'd have to do some crazy simplifying things there, and then it would come back to this. So I always go back to my original. So for my secant, the secant would just be the square root of 58 over 7. And then my cotangent there would be 7 over 3. So I'm just